Today I will discuss about Wald test by manually and using Python SPSS and with R code. This is the part 2. In part 1 I have discussed about multiple linear regression model. Hello friends, I am Dr. Nozrul Islam, Associate Professor, Department of Geography, Coachbehar Panchanan Burma University. I have already discussed in my part 1 of MLR model this table, and I also discussed this table in my previous video. Wald test is a statistical hypothesis test used to assess the significance of individual coefficients of independent variables in regression models, such as linear regression and generalized regression models. It helps to determine whether a particular coefficient significantly differs from a hypothesized value, typically 0, under the null hypothesis. The formula of Wald test is estimated coefficient minus hypothesized value divided by standard error of the estimated coefficient. Now question arises why we are using Wald test instead of student t-test. It is noted that student t-test is used to test the significance of the estimated coefficient similar to Wald test. In linear regression, you can perform t-test for individual coefficients. However, you usually use the t-test to evaluate whether the estimated coefficient is significantly different from the hypothesized value, not necessarily 0. Note that here in Wald test the hypothesized value is 0, but in t-test hypothesized value may be anything. Further, the student t-test is used to judge the significance of Pearson correlation coefficient. Now question arises why to use Wald test? To assess the significance of a specific coefficient in a regression model, it is also used to test whether the particular parameter has a meaningful effect on the outcome variable in a model. Similar any model or test, Wald test has also some steps. First we have to set null hypothesis. Here we have to take 3 null hypotheses because of we have 3 independent or predictor variables. So null hypothesis for beta 1 equal to 0, that means no effect of x1 on y, that means education level x1 has no effect on income y. Similarly, beta 2, null hypothesis of beta 2 equal to 0, that means years of work experience x2 has no effect on income y. Similarly, in beta 3 equal to 0, that means number of dependents x3 has no effect on income. In a nutshell, the Wald hypothesis, null hypothesis is that a specific coefficient, that is beta 1, beta 2 and beta 3 equals to hypothesized value, that is 0. As I have mentioned in the previous slide, the equation of Wald test, which is written here, that is beta I minus beta I hypothesized divided by standardized error of beta I. By using this formula, we determined the Wald test for beta 1, beta 2 and beta 3. So here beta 1, as we calculated in the previous slides as 1.1621 minus 0 divided by 0.55967 equal to 2.06764. Similarly, for wall test for beta 2 is 4.7510 and wall test for beta 3 is 0.3208. In step 3, we have to determine the critical value. We will get this critical value in chi-square table under the 5% significance level, that is alpha is 0.05, and under n minus k degrees of freedom, that is 10 minus 3 equal to 7, the critical value is 14.0671. In step 4, we have to compare Wald statistic to the critical value. If the Wald statistic exceeds the critical value at the chosen significance level, that is alpha equal to 0.05, and with particular degrees of freedom, you would reject the null hypothesis and conclude that the corresponding coefficient is statistically significant in the model. On the other hand, if the Wald statistics is less than the critical value, you would fail to reject the null hypothesis, suggesting that the coefficient is not statistically significant. You can see these are the three values of Wald test of beta 1, beta 2 and beta 3. All are smaller than the critical value. Now we have to take decision based on the Wald statistic, as we have found beta 1 2.0764, beta 2 4.7510 and beta 3 0.3208 are smaller than the critical chi-squared value of 14.0671. Therefore, we fail to reject the null hypothesis. In other words, we accept the null hypothesis at 0.05 significance level with n minus k, that is 10 minus 3 equal to 7 degrees of freedom. This suggests that the coefficient for education level x1, years of work experience x2 and number of dependents x3 do not have statistically significant impact on the dependent variable y, or are not in explaining the variation in the dependent variable y. And this is the code for determination of Wald test and critical value of chi-square by using Python code, and these are the results, similar result we get in the previous slides. Wald test in SPSS, it is noted that statistical software like SPSS cannot perform the Wald test directly, but we can easily perform manually. Once we get the values of MLR in SPSS, we can follow the following steps for performing the Wald test manually. So specify your hypothesis, as I have mentioned, hypotheses are same, and then calculate manually, as I have explained in the previous slides, how to calculate Wald test, that is Wald test statistic beta I minus hypothesis value of beta I and standardized of beta I, and replace your data and you will get the Wald statistic. Then you will also determine the critical value using chi-square table under particular alpha or level of significance and degrees of freedom, and you will compare the result as I have explained in conclusion part. This is the R code for Wald test, and you can copy this code and put in the R and you will get the result as I have discussed earlier. Thank you for watching my channel. Please subscribe my channel.